This is just a general talk about functional programming. I know that when I first tried to learn it, it didn't make any sense to me because I didn't understand why you would want to use it. And if it's any consolation, it's still not as big of a shift as prologue. So in any case, there's a wide range of functional and there are two main paradigms of there's functional and imperative. Most of the other ones fit under these two in some regards. Imperative languages are the ones that are taught at RPI right now. Of course, there's a lot more on both sides, but these are the main ones grouped by family. Anyway, what I won't talk about. Well, I'm probably wrong on at least a few things here. I'm not going to mention that. I'm not going to talk about Swift because it's an Apple language and I can't stand them. They have terrible syntax and they combine all of the unintuitive languages together. Or they combine all of these easy languages into something much less simple. So now you end up with something that resembles a combination of JavaScript and Bash. Anyway, there's also that schism between people who believe that functional programming is the way of the future and people who believe that it is pointless. It is pointless. That's also not pointless. So what's different about a functional programming language? I mean, largely it's a question of whether or not data is mutable, and whether or not you're encouraged to modify it. In C, you create a variable and you always end up assigning. You end up reusing it several times, probably. Whereas in a functional language, you never alter it, and instead just assign a new variable as it's transformed by functions. Hence functional. Most functional programming languages have higher order functions or second order functions. Anyway, you can pass functions to other functions so that they're called by that function and they do stuff with other data. That's very useful for working with lists.
So you can say that the standard of all functional programming languages is lambda calculus.
Yes, that's later on.
Oh, this is later on.
Okay, now all of this stuff requires a large shift in how you write your program. But there are benefits, probably. It really depends on what program you're writing, but in general, you can expect a simplified program design due to the immutable data. You can expect if you do your functional programming very functionally, pure as possible, you're never going to run into concurrency issues if you decide to make it concurrent. And most functional programming languages do their best to make code simple. I can't remember any of them that I listed that aren't so, unless you can. And you can also expect garbage collection because really, doing that manually is something that's best left for an imperative statement because that changes the program statement. Right? This is an example of a ridiculously trivial function. Iterates through a list, adds 3. Vocals on that side, it's less than half as long as the C++ code. Notice the lambda function here. That's what Morgan was talking about earlier. Wait, another one because you'll notice that you can't really see all of the C. I think that's probably preferable. Oh, and I misspelled Haskell. Okay, this is the last example, but this is from the project my group is working on. It computes a grammatical closure in order to build a parsing table. And this will take hundreds of lines of code in another language. in an imperative language. So again, why should you use this? Well, there's not really, you can't really quantify the benefits consistently because it's a program by program basis, but in general, it's likely that if you try programming something functionally, that you can have issues with imperative programming, then you might have an easier time. Or at the very least, it'll loosen up your brain a bit. Datum. So, more about immutable data. State has changed entirely. If variables have changed at all, they're generally only changed in what they refer to. Functions apply transformations to these variables and return the alternate information. Side effects should not exist. Altering information by pointers in C or C++ or reference types is most likely not functional. Side effects are bad. We should be careful around them. They're useful when you know that they're coming, but if you're careless, then you're going to probably end up doing something wrong. Anyway, if you probably actually all had that if you've taken data structures recently, you probably dealt with the misuse of side effects. And actually the definition of side effects is given by the C++ 11 specification in regards to the lambda functions that they just added. And it pretty much covers all of the things you would expect a functional programming language to be careful about. The biggest one here is probably this one. Especially since we're adding more processors instead of faster ones. If you have avoiding side effects makes turning your program into a multi-threaded one much simpler. Well, now if this sounds good, then you're still going to end up using some imperative parts. Mostly things like input and output are probably considered imperative even when inside of a functional programming language. Functional programming languages suffer from the malady of being fairly slow compared to C or C++. Especially Lisp, but that's because it's not compiled the same way. Lists are linked lists, which means that you can concatenate them as much as you want, but if you want to do random access, that's very expensive if you're going to be iterating over a large list. And if you do spend the time and learn one of these functional programming languages, it's fairly, they're very rarely used in enterprise software or production grade software, simply on the basis that there's generally not as many libraries for them, and the libraries there are generally.
But I think people do use functional programming without that knowledge somewhere. If you think of LaTeX as a programming language, or you have a markup document, you do some interpreter there, you don't have any side effect. Or do some side effect. But I think there may be places that people use functional programming without that knowledge.
Well, actually, one of the few places where you still find ML used is financial industry, surprisingly enough. But I mean, you're still relatively unlikely compared to you're more likely to be writing C or C++ to Lisp or OCaml. But anyway, there's a lot of benefits that you can get out of this if you learn to use it properly. And it's not in the language; it's in the paradigm. You can do it in C or C++. You could probably, you can't do it, it's harder to do in Java, but you can do it. There's not so much of a limit that you have to worry about as far as languages go. Anything that's any reasonable language is probably going to suit your needs. And immutable data is the devil. That's it. Are there any questions?
Yeah. The introduction of Swift by Apple, do you think that you'll be seeing much more functional programming in the enterprise?
I feel like the syntax is going, it's great that they wrote another language, but the issue that I always see with all of the Apple languages, whether or not they try for it, is that their syntax is ugly. If you see it in Objective-C, you see it in Objective-C++. I mean, when you refer to an option, a variable arguments in a function in Swift, you use a $sign with a number next to the argument, and that seems unclean. It reminds me more of Bash than it does of any proper programming.
Well, it would remind a lot of programmers to use a PHP.
Yeah, I have similar views about that. You also notice that I didn't mention PHP at all. Any other questions?
So regarding the speed of lift, is it, like according to that Norfolk benchmark, is common list like within a factor of 2 of C++?
Yes, but I mean, that's still slower, and if you don't...
But that's better than things like Java and Python.
Yeah.
Significantly better.
I didn't mention either of those in the performance because that would have negated the point that C and C++ are generally just very fast.
Which version of this are you referring to?
I'm not sure. I think it was probably SBCL.
Okay.
Anything else?
That would have a big
You want the right color.
In fact, to overcome the slowness of Lisp, they had long time ago they had Lisp machines which will execute Lisp programs directly on hardware. So that is what Lisp machines were very popular in early 1980s.
Anything else?
So the chart on the first and second slide with the languages, you have them separated horizontally by what their dominant paradigm was. But there also seemed to be a pattern in how they were separated vertically.
Well, I mean, they were separated vertically by the paradigm.
Okay, so then...
and then they were grouped horizontally by their syntactic conventions and which one they took after.
Okay.
Anything else?
And also about the libraries issue. For things like, I guess, Scala or some scheme dialects that run on the JVM, and I guess with F# for .NET, do those still have the problems with not having many libraries?
It's a different kind of support. There are a great number of companies that are offering performance solutions for C or C++ for whatever obscure fields that you want to know. If you want to really classify koalas or something, koala hair, based on its roughness and whether or not it's been shampooed recently, you're not going to have a library for that. You're probably not going to have a library for that in a functional language. Actually, I kind of hope that library doesn't exist at all. But there are a great deal of libraries for anything that's not esoteric. Are there any more questions?
So actually, about the libraries, fairly straightforward to access C code from OCaml.
Yes. Is that universal to functional languages, though?
Okay, never mind. So that's not in general.
Okay. Is that it?